All right. As the title suggests, I'm going to be talking about hacking back or attacking adversaries themselves. I am going to be popping some shells at the end of this, but the talk itself is not so much a focus on whatever exploits I've found. If there's anything that I'd like you to take away from this talk is that a lot of the rats that are used by nation states or state actors are very vulnerable. And so the takeaway I'd like is, like, if any of you are interested in vulnerability research, this is a very ripe field for the picking. A little bit about myself. I'm a senior security researcher for Symantec. Before that, I was with Blue Coat before they acquired us. I worked before that. I was with the Department of Defense, doing a lot of fun games. And then even before that, I was an IT manager, so I've done some time in the trenches. I kind of have a good perspective on this from all aspects, I feel. With that background, though, it should be pretty apparent that there are going to be some disclaimers. First off, I am not speaking for my employer, current or prior employer. Probably what I'm discussing with you is illegal for wherever you are. Maybe it's not, but if you get in any kind of trouble, please don't blame me. That being said, if you have some fun with this and you find something cool, I'd love to hear about it. So here's what kind of got me started down this path, and that was the sophisticated actor term. It really bothers me. It's this defeatist attitude that the defense has, like, oh, they were sophisticated, there's nothing we could have done, or they'll eventually get in, you know, I can just do my best. This defeatist attitude just not good for our community as an industry in general. It's just kind of it promotes doubt. I mean, who goes to a game, a soccer game, assuming they're going to lose? Yeah, you're going to lose if you're going to go in assuming you're going to lose, right? And furthermore, the term sophisticated, I'm not even sure what they're trying to convey with that word. Can you imagine how that conversation goes to the CEO when you've been hacked? Sir, we've been hacked. How do we get hacked? Well, they were sophisticated. How do you know they were sophisticated? They were wearing a monocle, so clearly they're a sophisticated actor. Yeah, I don't know what they try to portray, but for me, it's just an annoyance. And so that's why I went after these guys. I wanted to show that they're not as sophisticated in the fact that they play on the same playing field that we do, that they can be hacked, compromised, just like we can. Now, hacking back's not a new topic, right? It's been around, it goes on, it's been a hot topic for quite some time. It's recently resurfaced, but 5 years ago at Black Hat, they did an anonymous survey, and over 1/3 of the people surveyed admitted to hacking back in some form, right? It happens, it goes on, whether we like it or not. And then we bring up the AC/DC Act, which we've heard, right? It's now being presented that would allow, under circumstances, hacking back. So it's alive. And the general consensus is that this is not a game that you can win, right? Like most everybody agrees that if you hack back, you have very little to gain. You can't really delete your documents. Any movie star who's had their photos leaked online knows that that's just not going to happen, right? You try to delete them, you cause more trouble in the process. But even if you were to hack back, what do you have to gain? You just have things to lose, typically. The liability if you hack the wrong target, the lost productivity as your very senior guys are trying to hack somebody rather than fixing the problems you had in the first place. What if this gets disclosed publicly? You'll lose face, you'll lose reputation. Not to mention, if you do actually hack back, they had noticed this and then they decide to come at you double strong, right? Then you've got an escalation issue. And furthermore, what we've seen, or what people have said, the majority of the reason why companies hack back is it's out of a sense of revenge. Like, I want to do something. I know the government is not capable or won't respond, so I'm going to do something myself. And most of this response, like a revenge type attitude, is not useful at all. So you possibly RF the machine, right? They just spin up another VM somewhere else. You didn't do them any damage. Or it might not have even been their machine. It might have been somebody else's machine that they compromised. That being said, I do think there is a use for hacking back. I'm a security researcher, and as we all know, attribution is hard. But if you can observe what an attacker is doing, what they're targeting, what they're interested in, then that can tell you a lot about who the actor is. And that's where I feel that there's the most value in hacking back, is to learn about what the attacker's doing. And truthfully, that's what the ACDC Act is actually trying to do. From it, it says that you cannot hack back to destroy or cause physical or financial injury to the attacker, the adversary. But instead, you can only hack back for the purpose of establishing attribution of the criminal activity or to monitor the behavior of an attacker. So on that term, I kind of like the ACDC Act. Now, don't get me wrong, I don't think it's perfect by any means, but I think it gets us started on the right path. Obviously, I didn't come here, or you didn't come here to listen to me talk about what I think about ethics or what's legal or what's not legal. So I'm going to leave it at this, but just kind of say, were this bill to pass or were it legal in your country, here's what we could accomplish. Before I get going, I want to make some terminology clear. I've had some confusion with this in the past. I've heard people call the piece that runs on the victim the server, and then the command and control piece is the client. I don't really like that terminology, and I can't really use attacker versus victim because now we're hacking back, the attacker becomes the victim. So I'm going to try to refer to the original victim as the target, the one that controls the command and control server, or originally controlled the command and control server, as the adversary, and then the person doing the attacking back as the retaliator. I like that term because the definition is one who returns assault in kind, and that's what we're going to be doing. So a friend of mine, this is what got me started, a friend of mine took all of the APT reports that had been released by all the different groups and just kind of did a summary on which tools were the most cited rats amongst those APT, or sophisticated actor reports. And he posted this tweet. And when I saw that, I was like, this will make the perfect shopping list for me. I will just start at the top of the list, see if I can find anything, a bug, an exploit, and work my way down the list. Now, some of you may already know, Poison Ivy, which topped that list, there's already an exploit for that out there. This was found a few years ago by the individuals at the bottom of the list. I'm not going to say their names because I totally screw it up. But the exploit is a buffer overflow, which would allow remote code execution. And as many of you know, because some of you in the audience are part of it, the Malware.lu guys, and in partnership with iTrust Consulting, noticed after the Mandiant did their APT1 report that the actor was using the Poison Ivy rat. And so after getting permission or working with the local cert, somebody can correct me after this if I paraphrase the report wrong, they used the Poison Ivy exploit to get back onto the AP1's infrastructure. And they documented their findings, which is astounding. It's one of the rare cases where hacking back has been documented publicly. And what they found, they were able to reveal their infrastructure, how they work internally, additional tools that weren't known before, and their TTPs, how they work, what indicators to look for of this hacking group. It was extremely insightful, and it's a very good proof case that hacking back can be very useful as a defender because the knowledge that we all gained about how this actor worked because of the work that these guys did. Also on that list that had already been exploited is Dark Comet. The exploit is a remote file disclosure vulnerability. I've not heard of this being used publicly. I'm sure it is, but there's no public report. However, I felt like I should announce it just out of completeness. So with that out of the way, I just started this at the next down, the second item on the list, and then I just did the top three. I figured if I can find bugs in the top three, that's pretty good. I didn't want to keep walking through. It would just kind of prove my point. I'm going to talk about them, however, in reverse order, in order of what I feel the least interesting to the most interesting. So number 3 on my list of interesting rats was Extreme Rat. Who here is an incident responder? 1, 2. How many of you, who's here familiar with Extreme Rat? Just out of curiosity. Okay, a few hands. It's not one of the most common, but it is still a rather popular tool. It's typically used more by script kiddies, but it does see a lot of sophisticated actor use as well. This is a screenshot from the command and control component. I have one victim, and if you right-click, you can see the capabilities that the command and control component has on that victim. Kind of the standard set. You can see a screenshot. It always takes a little thumbnail occasionally, just so you can see the screen of the victim. It's really a kind of basic tool set. However, I mentioned it was targeted more towards script kiddies. Some of the features in there, one of them, for example, is while you're waiting for them to click on that phishing email, you can play a little Jewel quest. If you get bored, I don't know. But the fact that that's included in there kind of made me laugh. However, that being said, Extreme Rat is used or has been cited in some sophisticated reports against Gaza Strip. I think there was some against targeting Israel. A lot in the Middle East. And so I gave it a look. Now, Extreme Rat is very easy to observe in your network, right? There's a very unique pattern to identify it. When it calls home either TCP or a fake HTTP request. The TCP request always starts out with my version pipe, some number, the version, right? 3.6, 3.7, 3.8, whatever. And then the server responds with an X carriage feed line return. Very easy to make a snort signature for. The alternative is a fake HTTP request. It just sends this request header, but then it reverts back to a raw TCP connection after that. And the request always takes the form of get/somenumber.functions. The some number is like the password that the command and control adversary enters when he starts up his client. And the password has to be all numbers. So it's a really easy to write a regex for that URL type pattern. If you see that, you've been hit with this bug. As I was researching this rat, I noticed one particular pattern that stood out to me, and that was when the adversary wants to push a tool down to his target. And what it does is it sends a message to the target component and says, hey, get ready to receive my file, tool.bad, and you're going to save it to this C drive / temps, maybe call it count.exe. And then the target component responds, okay, I'm ready to receive your file called tool.bad, and then the data is transferred. And what stood out to me was, why is the target component at all told where the file is stored on the adversary's computer, right? Like that seems like an information disclosure bug to me. Not a big issue, but I thought the only reason it would be telling the target piece that information is if it didn't want to keep state, meaning when the target responds, I'm ready to receive tool.bad.exe, that's all that the server component needs to know to then fire the response. Since it doesn't need to keep state, then I guessed you probably don't actually need the first message at all, right? If the target component just solicited, hey, I'm ready to receive this file, then sure enough, the server responds. So I could request any file I want from the server, and it will just hand it from me. So this is known as a blind file retrieval type bug. I can't receive a directory, unfortunately, but this is something that pen testers come across kind of often, so they've thought about this and kind of written up some good things to pull. Maybe you want to start with WinINI, because that should exist on all versions of Windows. If you can pull that file, then it's kind of a sanity check that everything works. But it also should reveal what version of Windows you have. And if you know what versions of Windows that the adversary is running, then you can pull the event logs. If you can pull the event logs, then there's a good chance you will find other interesting folders. Maybe you can identify the user that's running those items. If you know the user, then you can pull their desktop.ini, which will say what folders they have on their desktop. And then you can start walking this path and kind of gathering information. If they're running as admin, which is often the case, then you can pull the backup of the registry, which will pull lots of great information, or maybe a backup of their SAM database, and then crack their hashes, and you can log in directly to the box, maybe if they have RDP open. These are just ideas. The link at the bottom shows other things that are worth looking at, trying to retrieve. But with that, I figured, no, that's good enough for Extreme Rat. It's not a big threat to me, so I figured good proof of concept. So I moved on to the next one. Who here has seen PlugX, or CorePlug, or Distore, whatever you want to call it before in your cases? All right, a few more hands. This one's kind of popular in the Asia region. This is, again, one victim, and the second pop-up screen is the capabilities you have on that victim. This one has a few more features. One of them that I find interesting is you can directly access a SQL server. So if the target machine is a SQL server, then you can start querying the data directly through this tool. It's also got other things for scanning, telnets in there. You know, it's the common feature set. But this one has been cited in a lot more APT cases. I have not seen a case where PlugX has been used and it hasn't been called a sophisticated actor. Not to say that it's not being used by them, but everybody seems to say, if PlugX, then sophisticated. Some of the key reports that I want to point out is down here at the Black Hat Asia one. I know you want me unplugging PlugX. These guys did a great write-up on the different variants of PlugX that are out there, what it's used for, who's using it, what groups are using it. And that provided a lot of great background information and understanding of the binary for me so I could do my work. We don't have source code for this one, so I started by doing some fuzzing, but it turned out that this thing is extremely crappy, because as I fuzzed it, it would fall over left and right, and I got all sorts of errors. Some looked more promising than others, but I had so many that I really still didn't have a good, clear place I wanted to start. It's like, oh, this is fishing's too, or the yard to look for vulnerabilities is too broad. So I fell back to just doing static analysis. And one of the first things I was looking for with static analysis was a buffer overflow, because I felt like that would be the easiest. And so here's some code that handles a message, or a packet as they call it, from the target back to the adversary. And what it does is it makes sure that the message is small enough to fit on the buffer, right? Like that's what it's trying to do. If it's not smaller than F000, which is a large packet, then it goes down to show this error message and skips out. However, this particular code comes after the memory has been copied onto the stack. So it copies the memory onto the buffer and then checks, oh, wait, was there enough room to do this? And if there's not, then it shows the error message, but then returns from the function. So I get code execution after the error message, which is very descriptive for the user, right? This clearly tells what just happened. Turns out this PE to code packet message is just kind of their generic something went wrong message. If you nmap the machine, it'll show one of these. So it's very unclear to the adversary what just happened. And it doesn't matter how it's acknowledged, if they click the X or they click the OK. Either way, as soon as this pop-up goes away, then code flow returns to the stack, which has been corrupted, which means I get execution. So I have a quick demo here of this. Let's see if we can get this started. All right. Oh, that did not work. So on the left side of the screen, I have what I'm representing as the retaliator, and on the right side is the adversary. I have Metasploit running on the left side. I should start up PlugX here, and then I will fire up the Metasploit module I've written for this. These Metasploit modules are now in the repository, so you guys are free to play with these at any time after this. I just point my Metasploit module at the target. We'll talk about how you can figure out where your target is later. Now, there's 3 variants of PlugX out there. There's 3 different types. I named them just after the last talk, the one I pointed out before in Asia. And you can just run a check, and it'll tell you if you've got the right target. Now, I run my exploit. You see the pop-up message there. As soon as they acknowledge it in some sort of way, here comes my interpreter session spawning up. I think I just run like sysinfo and pop a shell, and then as proof, as proof, I start an OPAB on the adversary. So boom, we have execution on their machine. Then on to my last one, Ghost Rat. Ghost Rat has been around for years. It's seen in quite a lot of cases. Who's seen Ghost Rat? Hands? All right, yes, the most hands on that one. This guy has been around for at least 10 years. It's kind of like the basic rat. Like everybody compares, oh, do you have the features that Ghost Rat does? Because that's kind of like the baseline of rat capabilities. You see the right click, just the standard stuff. And Ghost Rat has been cited in a lot of things over the years. Most recently, I've seen it being spread via Eternal Blue. So it's still being used. 10-year-old rat, they're still throwing it with latest exploits. It's just kind of a staple for the group. Again, very popular in Asia-Pacific regions. It's very easy to identify the traffic. It always starts out with a 5-byte header that's typically ghost, spelled with a 0. Now, the source code for this was leaked online a few years ago. And after that, then the group started realizing, hey, this ghost pattern is really easy to detect. So they tried to modify it. But they usually just modify it by changing it to a different 5-byte pattern. Sonora, a colleague of mine, generated this list right here. These are all the different variants that we've seen in the wild. One of those is 6 characters. The rest are all 5. And again, even if you change that up, the pattern is still that 5-byte magic header, a 4-byte size, and then a zlib compressed buffer. So it's very easy to identify this traffic, even if they change that up. And as I did my research into it, I saw a similar vulnerability to the extreme rat, but this time the other way. So when the adversary wants to pull a file from target, they'll send that typical message, give me your file.doc so I can save it to my stash.file.doc. Then the target responds back, here's the data, so you can save it to this folder. And sure enough, the first message isn't needed. So I can say, oh, here's the data, save it to startup.whatever.exe, right? And there you go, you've got a backdoor. No, now Windows isn't that easy because Windows changes the path to startup every once in a while. So different versions of Windows has it in different places. So I wanted something better. And it turns out that GhostBrat also has a sideload vulnerability. So if you drop a file called OLE DLG in the same folder, which is just like the default folder, right? Then it will try to load this when it starts up, and it's only looking for one export from that DLL, and that is OLE busy, which is basically just asking, is it all right if I make the UI busy? So if you make a simple function called that and return true, then GhostBrat will load this and be none the wiser that it has just been backdoored. So you can backdoor their backdoor. Well, this is pretty good, but this still, before it takes effect, it still requires GhostBrat to be shut down and restarted, and I wanted something more immediate. So I kept looking. Now, like I said, the source code for GhostBrat has been put online, and source code is a lot easier to look for bugs, right, than looking through the static analysis. And sure enough, look in a short scan, I found that they are mem setting this buffer to 0, which is called remote drive list, and then they copy to that buffer a buffer they got from the target, and they copy the size based on the size of the target buffer. So it's a buffer overflow into a C+ class. The thing I override is on line 45. It's a 1024 character buffer. It's meant to store the drives that the machine has, C, D, E, and Z, And so they figured, oh, well, it's only going to be 26 at max. So that figure 124 should be enough, right? Well, I can come up with a lot more drives than 124. Enough that I can overwrite something in this structure. I chose to overwrite one of these subclasses. And so when that subclass is accessed, it's a function of the subclass. So that means I need to control a pointer to a pointer, which is not really fun unless I know where I am in memory, which means I need to know I need another bug that would give me an information disclosure to show me where I was in memory. I was lazy at this point. Instead of doing that, I took the easy mens route and just sprayed the heap, so I knew I'd be just about anywhere. And then with a good probability, I would just jump to my heap that's got like a big sled, the old school way. Dep would break this. However, I could not get Ghost to run on any server that I had Dep enabled. Apparently something about how Ghost is set up that it just breaks with Dep. So wherever Ghost is, Dep's not running, so I didn't really have to worry about that mitigation. Now, before I show that one in use, I have a demo for that one, I wanted to talk about some work here by Kev the Hermit. He's written decoders for all these different rats, meaning if you've found a piece of the malware, you can run this script on it, and it will extract from that piece of malware the C2 information and the configuration information. So if you are hit by a piece of malware and you identify it as one of these, you can run his script on it, find out where the target is, and then use my exploits to hack back against your assailant. Or if you don't want to wait, Shodan recently added a feature known as the Malware Hunter. And one of the types of servers they look for is a GhostBrat server. So we can simply just do a search on Shodan, find yourself some nice targets, and start hacking. So with that, let me start my demo again. Same story. On the right is the adversary. On the left is the retaliator. This time I'm going to change it up just a little bit, as I'm going to generate a piece of malware from the adversary, and we'll just get that in some sort of way. Usually it's like phishing, right? So in this case, since it's just a VM, I'm just going to drag it out. I closed the GhostBrat for some, I don't know, I wasn't thinking. But anyways, I just dragged out my server components here. Now I'm going to run the rat decoder script that Kev wrote on my piece of malware. And there it shows the IP address, the port of the C2 server. So I'm then going to, I realized I shut down the C2 server, start it back up. I'm going to fire up Metasploit and use my exploit using the information we pulled from the malware and target them right back. Show and fail, just make sure everything looks good. If they use a different magic, we can change that in the config. If you run a check, it'll say, hey, I think they're using this magic. So you can just update your magic to match whatever they're using. And then I run the exploit. Now it's going to take a while because I do a large heap spray. I want to make sure I have a good probability of landing in my code. And then after it feels comfortable, throws the exploit. I got my session. For some reason, my session hangs for a minute. But once it comes back to me, then I'll do the same sysinfo, spawn a shell, and I think this time I spawned calc as my proof. Boom. So now the question is, what next, right? You land on an adversary's box, what should you do? I'm not sure, but I have some suggestions. Maybe you would want to run netstat, right? Because that will show if they have hooks into anybody else, if anybody else is a victim, it should show their connection. You would see get the IP of the other victims. Maybe you have other machines in your enterprise that have been compromised. This would show any of them. It would also show if they have an RDP connection in, if this is like a VM box for them. Maybe you want to start walking the file system, seeing what they stole from you, seeing what they stole from others. That would give you a good idea of what they're interested in or what kind of documents they're after. So that might give you an idea of why you were targeted. Maybe you want to install your own persistence, put a keylogger on there, steal their cred, start enumerating their network. I'm not sure. Maybe these are bad ideas. Maybe they're good. That needs to be a discussion that still needs to be had. But whatever you decide to do, I highly recommend that you stay quiet and observe, not go the destructive route. This is supposed to be a picture of Sun Tzu in ASCII art. I don't know if you can make that out. But right, if we sit quiet, we listen, we observe more about our adversary, and then we can do better defending ourselves. So for that, thank you for sitting through my talk. Thank you.
Thanks, Waylon. Questions? Questions? You've got a question. No, he doesn't. Any questions? Okay, well, Waylon's going to be around, so you think something you want to talk to him about later, he'll be around.
Yes, if you do disagree with any of my theories or ethics on this, please come talk to me. I'm an open door on that. I'd love to hear your opinions. Thank you.
Okay, thanks, Waylon.